In this class, we're going to be showing how to differentiate a function to the power of a function. But we need to know the basis of differentiation. Recall from our basic formula, y is equals to x to the power of n. That means the y over the x is nx, n minus 1. Suppose you're asked to do y, the x to the power of n. What you need to do firstly is to introduce a natural logarithm to both sides. So this can be easy to solve. So I'm going to have ln of y. Remember, for logarithm the power falls to the other end, which means I'm going to have x to the ln of x. So in that case, I'm going to be having the y over the x, 1 over y, because when I differentiate this, for a ln function, for me to differentiate a ln function of x, I'm going to be differentiating the function over the main function. That's how I got 1. Differentiate y, I'm going to have 1 over the y. Okay, so the next one, to actually differentiate this, I need to make use of my product rule. And the product rule is v du over dx plus u dv over dx. Okay, so here I assume that this is my u, this is my v. Anyone can be your u and anyone can be your v, depends on you. Which means my u is equals to x, then the u will be equals to 1. My v is equal to ln of x, then my dv is equals to 1 over x, just from this function that we stated above. So trying to put this into it, I'm going to have my v to be ln of x, then my du here, my du is 1. Du is 1 plus my u is x, then my dv is 1 over x. From this, I know that this cancels this. Moving on to the next one, I have dy over dx, 1 over y, which gives me ln of x plus 1. Mind you, I only need dy over dx, so I need to move this to the other side. In that case, I'm going to have dy over dx equals the ln of x plus 1. Then multiply both sides by this y, the y comes here. Don't forget from our question, our y is giving us the ln of, is giving us x raised to the power x. Therefore, the y over the x will now be ln of x plus 1 x raised to the power x.